Good morning, everyone, and welcome to our Dynamic Dialog webinar. This is July 27th. As usual, it's a Tuesday. We have a new time frame that we're starting now in July. This is our first time. We're going to start at 11:15 a.m. Pacific. So we'll try to go 45 minutes, be finished by noon. Occasionally, we might go a couple minutes over, but definitely we'll keep it to less than an hour. So for now through the end of the year, we have a new time, which is 11:15, and a new link, which I sent out, and that is good for July through December. So thank you everyone for attending live, and thank you for those of you who listen online. So today we're going to talk about lean supply chains, and I found this Dilbert comic, which I think kind of captures what a lot of people think about lean. So here's the manager, and he says, I just read this great book about how to lean our business processes. And Dilbert, of course, says, uh-oh. And the manager says, everybody's doing it. We'd better jump under the bandwagon before the train leaves the station. And I'm putting you in charge. So you can see Dilbert is a little bit pondering that. And of course, if you need any management support, you know where to go. And of course, Dilbert knows where to go for that. So lean is a scary thing. It is one of those kind of buzzwords where people are talking about it a lot. There's a lot written about it, a lot offered about it, but we're going to talk about why companies bother to go to lean. I'm also going to talk about Six Sigma, but I'm going to put a lot of emphasis on lean because I think that's a really good place to start. It's a lot easier than tackling some of the statistics with Six Sigma, but Six Sigma has a lot of potential too for many businesses. So why do companies bother with this? They need and they want improvements, and those improvements come in processes, procedures, and most of all, they want better results than they've been getting. That old phrase of faster, better, cheaper still applies. Companies are still looking for that, but it also applies to say that if you keep doing the same thing over and over again and expecting different results, it's just not going to happen. That's the attributed to Einstein is the definition of insanity. So I'm not sure if Einstein said that, but I think that is pretty profound to say if you keep doing the same thing, you're not going to get different results. So companies want faster time to market, faster product development. They need time to upgrade. They want faster upgrades, and they want faster changes implemented. They need better quality, technology, flexibility, agility, responsiveness, customer satisfaction, all of these things that we hear so much about. But also they want better financial results. They want better return on investment, return on assets, higher inventory turns, better profit margins, all of these things that companies talk about over and over and over. That's what they're still looking for. So they want to get this with less direct and indirect costs, fewer implementation dollars, and at lower prices. So there's so many things that companies want, but they don't have budgets for big programs. They don't have time to take the next year to do something. It's really, how can we implement things incrementally? So all of this is driving what companies are doing. And these lean tools really apply when there's not a lot of budget, not a lot of time, but companies know they want something different. So lean tools help you simplify the processes. They help you increase your speed. They increase the flow of material, increase the flow of communication, increase the flow of product across the supply chain, increase the flow throughout the supply chain. They help you minimize inventories, and they also help you error-proof processes. And that's an important concept we'll talk about in just a minute. So there's a lot of reasons that you can do these kinds of things. So at the basic, Toyota production system is where Lean and Six Sigma really got a lot of traction. So Taiichi Ono, who is one of the founding people and wrote the Toyota production system book, said, all we're trying to do is shorten the timeline from order receipt to cash, to collecting cash collection for the goods and services provided. So that makes sense for any company. You want to shorten the timeline from the time you get the order till the time you can collect the cash. Being lean, it is at its essence eliminating waste and not relying on particular subject matter experts. It takes that knowledge and that information and puts it throughout the organization so that you still have subject matter experts, but you don't have everyone relying on a single point of failure in one person or even a couple different people. So eliminating that waste also helps everybody and makes a better workplace. It helps everybody do better. So we're trying to take out time from processes. We're trying to take out material in the form of maybe scrap or rework or excess material. If we can eliminate waste in that, then that's a good thing. And again, we're trying to generate this nice, smooth flow of material from suppliers to manufacturers to retailers to the customers. So we want this nice, smooth flow of material accompanied by a smooth flow of communication and information and a smooth flow of cash so that companies can get the cash from their customers more easily, more readily, more timely manner. Six Sigma really is statistically based and it reduces variation, which is a great thing to do. It takes that variation within a process and helps you drive that down so that you don't have as many defects, you don't have as many outliers, you don't have as many problems with that process. Six Sigma by definition is 3.4 defects per million opportunities. So you can see that it's statistically based because many, many companies never make a million of anything. So you don't have to make a million and count everything to see that you have the 3.4. There's statistical tools to allow you to do that. But if you do have if you have Six Sigma quality, then if you had a million opportunities, you should only see 3.4 defects. And again, you don't see 0.4 of a defect, you either see 3 or 4 defects, but you get the idea. There's a lot of taking that process down and having very good reliability within that process. And that's what we're trying to do. So again, lean is finding the waste. These are some Japanese words that are used pretty readily and pretty commonly in manufacturing. Muda means waste. And again, lean techniques really try to take the waste out. So remove the muda. Kaizen is a word meaning change for good, continuous improvement. Kaizen is also a word that's applied to activities done in the workplace that are quick, fast, kind of focused in one area, maybe a couple of hours, maybe a day, maybe 2, but not much more than that. These are not long projects, but they're quick opportunities to find the low-hanging fruit, to find the things and identify the things that are the biggest problems that can be fixed quickly and then start to get some standardization. Kanbans are visual signals. They are often cards, laminated cards. They're colorful, sometimes red, yellow, orange, and they tell you that you either need to get more to a station or that you have product at a station that's ready to move to another one. I talked about error proofing. So this word in Japan, poke-yoke, is to error proof. So my best example of this is the ATM machine that I use has a feature where I put in my card and then I put my code in, I put my withdrawal figures in and hit enter, and then it gives me my card back. It doesn't give me my money until I get my card and actually remove it from the machine. So that's saying I can't leave my card in that machine, which many of us have done over the years. And I know that was when these machines first came out, I'm old enough to remember newer machines, that people would leave their cards there. So whoever makes the machine that I use the most often has figured it out that you don't get your money until you remove your card. So you have to remove your card from the machine and you get your money. So there's no way I'm going to leave my card in the machine. Then there's a couple other words, muri, to overburden, and that applies to people or machines. Mura, which is inconsistency. Gemba is an actual place. So it's also a Gemba walk, which is kind of a walk the factory, management by walking around. It's akin to that. It's not exactly that, but you do the Gemba walk to actually put your eyes on what's happening in the process. Kata is the order that you do things in. It relates to processes. Genshi, Gembetsu, and Gembutsu, excuse my language, anyone who speaks Japanese, I obviously do not. But that is the term to go see for yourself, go verify that. And Obeya is like a war room. It's a large room. It's an arena for discussions, but it's also a room where you don't have the use of the room the whole time, but it's where you can break to. It's maybe like a sidebar, but it's also a place where you can use it as a war room and look at some deeper discussions, put things on the wall, draw on whiteboards or whatever. So those are some terms you might hear from time to time. The 5 elements of lean are, they call them the 5 S's. And you can see the words, the Japanese words on the left side. And then these are the words, and not exactly, but these are 5 S words in English that people have translated into to help us look at what we can do to perform the 5 S's. So the first one is really about reducing clutter. Take all the non-essential things from your workspace. I always use the example of this when you either clean your kitchen cabinets or you clean out your closet. So you go through and you look at the things, what am I not using? So I might have a bread maker in here that's front and center, but I haven't used it in 6 months. So I'm going to put it more toward the back, or maybe I'm going to get rid of it. Or you may have a bread maker that you've used multiple times, and in the last year because of the pandemic, and every time you have to dig it out from the back of your cabinet. And you've decided that because I'm going to make bread every week or every couple of weeks, now I want to find a better place for that bread maker so I can get it out more easily and more readily. So you're reducing the clutter and getting rid of the things that are non-essential from the space that you're doing. You can think about cleaning off your desk as well. Then the second one is straighten. So you straighten, or it's also called set in order. So this is the old adage about a place for everything and everything in its place. So this is where you'll see workstations where they actually draw the outline of the tape, or maybe the stapler, or you have things on your desk where this goes in the right-hand corner, this goes in the left-hand corner, my computer's in the middle, and my pad of paper or my phone sits next to me so I can answer it or pick it up and dial it. So you're establishing where you want things to be, and then you set that place and you mark that for that. In your closet, it's putting things, okay, I'm going to put my shirts in this area, my skirts or my slacks in this area. Maybe I'm going to do this by work clothes, and then workout clothes, and maybe just leisure clothes. So however you do that, in your kitchen, you may say, I'm going to put all my baking stuff in one area and all my stovetop cooking stuff in another area, my utensils in one area, maybe my appliances, things like blenders and bread makers and rice makers and all of those things in another area. But however you decide to do that, you set it in order, and then you establish that place. You don't have to necessarily mark it, but it's a good thing to do. Then you want to make sure you clean the area, clean all the tools, all the machines, all the equipment. So the Japanese words translates to nearly new. So this is what we're trying to do. And you want to make this, in this third step, you don't, so you get rid of the clutter, then you set things in order, and then you do the cleaning. So you do it then because what you want to do is to make sure that any nonconformities really stand out, that they're obvious. So in a factory, it's things like oil spills, paint drips, maybe off-fall from an operation. Those are easily identified or cleaned. In your closet, it's maybe something that hasn't been there before, or something that you couldn't part with the first time that becomes more obvious as you're moving things around it. In your kitchen, it's things like, okay, now I have a nonconformity, maybe something is broken or something's missing a lid, or there's an uneven number of glasses, whatever the thing is, it's going to stand out after you clean everything and make sure you have everything neatened up. The fourth step is making sure that the first three steps really stick, or they're not difficult to follow. So you get a process, you get something that's easy. So you're looking at your workstations that accomplish a certain operation. You want them to follow the same pattern. You want identical markings at your workstations from place to place. In your home, it's, can anybody unload the dishwasher and put things back where they belong? Or when I buy something new in my closet, or I do a load of laundry or 2 or 3 loads because I may combine them all together, can I put my closet back in place in the same way? Can anybody in the house unload the dishwasher and put things back where they go? You want these things, these first 3 steps, again, to stick so that you're not having to redo this. If you're like me, you have to clean out your closet every so often. Maybe it's only every couple years, maybe it's every 6 months. Some people do this just as a matter of routine. Other people wait till it gets really bad and then go in and tackle the whole thing, and it takes 3 days to do it. A garage is another area that's typical for people to have so cluttered and so disorganized that it takes 3 days to get through it and clean it. So you want things that you can put things back clearly, easily, that you have a system that's easy to recognize, easy to follow, easy to repeat, because you're adopting these markings, indicators, whatever it is that's going to help you say, oh, yes, I want to do this in this way. And then, so that's the standardizing piece. And then sustaining is the 5th piece. This really means you're going to be sustaining this. And so if you get your closet cleaned up, okay, I got my closet cleaned up. Now I'm going to work on my husband's side, or maybe I'm going to work with, if you have children, maybe you're going to work with them, or maybe you got the kitchen done. Now you'd like to tackle the garage or another part of the house. So workstations are the same thing. Once you get a workstation set up correctly, you want to migrate that and move that those techniques and that result to other areas of the factory so that you have this sustaining culture with that. Some businesses today add a 6th S for safety. I don't know if there's a Japanese word or if it starts with an S, but I've worked in factories most of my career, and safety is paramount in all factories. So some argue that safety is already built into these other steps, but in my experience, you can't emphasize safety enough. So if you want to add that in as the 6th S, be my guest. Lean values really are important for organizations because lean helps you think about things from the customer perspective. When you're looking at the waste, you say, where is the waste, but what does the customer see? What am I doing for the customer? You're putting the customer there in where they should be, a lot of the focus. So if it's not helping your customer or ultimately contributing to customer satisfaction, then you want to say, is this really necessary? Is that something that becomes more of the waste category? So you want to listen to the voice of the customer, and a lot of lean techniques go around doing activities around that. And then making changes because your customer changes, your customer wants something different or more or less, or gives you that different perspective. So you're changing hats from being the supplier to being the customer. And if you bounce back and forth with that, and if you're a customer, if you do that from your supplier's perspective as well, you're going to learn some things. If you think about what you do as a company, as a customer, and then you say, oh, if I think about this from the supplier side, it may be different. It may be give you some insights into what you can do differently or do better. So the other term they use is to become the patient. And in this case, we want to walk through that entire value stream and understand what happens and how did you get here. So you want to do the one that's being diagnosed looking at the process as a patient, and you want to really become that. Look at it from end to end, from where it starts for you and your company and where it ends through that value stream, and understand, how did we get here and what can we do to make this better? There's 5 M's and 1 E that are typically used in this process. And the 4 I learned as an industrial engineer many years ago: man, method, machine, and material. So these 5 M's, maybe now the man term is not as politically correct as it was, but it just means look at the people aspect. And for me, it was easier to remember when I thought about the 4 M's. You're looking at material in all shapes: direct material, indirect material, scrap, rework, all of those things you want to consider. Machines, anything, it doesn't have to be a big expensive machine, but anything that moves or anything that has a moving part. A machine in this analysis could really be looking at a screwdriver or a drill, an electric drill, something that is a pair of scissors. If it's a hand tool and it moves, it can be considered in that machine category. It doesn't have to be multi-$1,000 milling machine. And then methods are processes. So is there a standard process? Is there a default process? And are people using that? Is it working? If it's not, if they're not using it, why not? And if it's not working, then maybe the process needs to be changed. So you want to examine that. They've added measurement or metrics to this, because it doesn't help you to go through and do all of this analysis if you can't set a baseline and then measure your improvement. So you want to be able to measure the magnitude of the changes that you're implementing and understand how you're improving the area or the results that you want to improve. And then finally, environment. This includes the culture. This includes the attitudes. This includes the environment related to maybe how much resources are available to make an improvement project. So look at your environment. What can you do? What is facilitating change? What is hindering change? And what can you do to make that work for you in the way that you'd like it to work? One of the things with Lean is really always use cross-functional teams. It's very important that you don't have everyone who does the same thing every day looking at something for improvement. It's good that you have the people that are doing the job day to day to look at that, but bring somebody else in from a different perspective. If you're doing an activity on a production floor, you might get your production operators, but you might add a quality person in there. You might add an industrial or manufacturing engineer into the mix. You might add a planner or a buyer into the mix to understand, to give another perspective. And it will teach that extra person something, and you're also going to get something into that group that the group that does that job every day doesn't see. And I said add one, but you can add multiple people. You don't want to have 40 people doing a project, but 4, 5, 6, maybe even as many as 8 can do a really good job with a lean activity very quickly and come up with some great results. So cross-functional teams are very, very powerful. So there's some other lean tools and techniques. When we think of waste, we usually think of time, labor, material. So we think of material and time, and then the labor piece of it is a little bit different than the time, because time could be cycle time, production time, whatever. And then labor usually has to do with either a person or the machine labor. So however you think of waste. But there's lots of other forms of waste that you can look at. And when we talk about lean, we define waste as any effort or expense that doesn't transform the raw materials into an item or a product that the customer is willing to pay for. So it really has to be, again, that value add, that value stream. What is the customer willing to pay for? So they talked about, when they created the Toyota production system, they talked about 7 forms of waste, but they added the 8th when it was adopted into the Western world, and you'll see why. So the first type of waste is defects. This is not just bad product, which we always think about, rejected parts or parts that come in the door that aren't accepted because they're not good. But it can be poor or missing documentation. And that can be the process, that can be the invoice that was sent in or the packing slip. This can also be lack of process controls or lack of documented processes, improperly maintained tools and or machinery, or it can be errors that we have like incorrect inventory balances. If something happens that is defective, is not correct, that's a defect. The second waste is excess processing. So this is a sign of a poorly designed process. It can include management issues like lack or poor communication, redundancies, or maybe duplication of things like data, or it can be related to using the wrong tool, a poor layout, using equipment other than the way it's really intended to do. If you kind of do a stopgap error or kind of cob something together to do that. So if you're processing more than you need to, then that's not a good thing. Overproduction, we always talk about shortages and then excess, but overproduction in the lean vernacular is pretty severe. In lean, the optimal lot size is 1. So you don't produce one item over and above your actual demand. A lot of companies don't feel comfortable adapting that, so they end up with lot sizes, and they don't want the paperwork involved with having paperwork for many lot sizes of 1, so they put those together. But what they're really talking about is to be careful, because producing in standard lot sizes can be really good for production. They like to optimize their equipment and their utilization and keep people busy. But it may not be lean if you're overproducing. And keep in mind that batch production can also mask defects that can be readily apparent if lots are sized to the demand quantities, to the exact demand quantities. For example, unless you have continuous and stable demand, you're doing large lot production. And this really is not lean. If you are producing always in lots of 100 and you only have orders for 60 or 70 parts, then you're producing extra ones every time. If you do happen to have extra defects or some yield issues in there, or some shrinkage within the production process, you're not going to notice, because you only need to ship 67 of that 100 that you produce. And you say, well, I'm continuing to produce this. I'm going to sell the 67, and whatever is left over, I'm going to put in to inventory because I will sell that. And maybe I make 3 lots and I end up with over 100 pieces. So the next time I get an order, I can just fill it. I don't have to create an order and do another work order in the system. And I have production, I have inventory available to sell to customers on demand. That may work, but it, again, may not be the most lean technique to look at. So you want to look at how much overproduction you have, how many items over and above the customer demand. Now, this relates again more to pull systems than to push systems, but think about what you're doing with your business and see what applies. The next one is waiting or wait times. So this can be applied to products, to work in process, to materials themselves. It can be idle equipment, and it can also be people who are waiting and don't have things to do on a continuous basis. Waiting can cost your company a lot of money in terms of direct labor, in terms of overhead, and things like overtime and expediting come from this. So waiting in one area can result in overtime and expediting down the line. So, and you can expedite the labor, the time, and the materials, and that can be very costly for a company. So when you're starting and stopping jobs a lot versus you having a steady flow of material through the production center and through the supply chain, this can affect your productivity and your profitability. So building wait times into your process is not necessarily bad, but excessive waiting and unplanned waiting can be not a good thing. And if you have a lot of material sitting on the production floor in WIP, increasing your inventory, that's not a good thing either. And then that brings us to inventory. So inventory is considered a waste due to the cost of handling that and holding that inventory. So that encompasses receiving, transacting into and out of a warehouse or an inventory location, security costs, insurance costs, and floor space that you have to have for warehousing. And this applies to raw, WIP, and finished goods inventories, and some other inventories as well. So I'm not saying that all of inventory is a waste, because if you don't have raw materials, you can't put anything into WIP and you can't produce goods. And then if you don't have WIP, you're not going to get finished goods, and then you have nothing to sell. But many companies have excessive inventory. They carry a lot of safety stock, or they may have long transportation times where your inventory is tied up, either inbound or outbound inventory that your company owns and is paying for. So look at, again, your processes and see where the waste is potentially in your inventory. If you have slow moving inventory, that could be a waste, and definitely excess and obsolete inventory falls into that waste category. So if you have a lot of that, it's important to take a look at that every so often and figure out how you can reduce that. Motion is the last of the traditional 7 wastes. And again, it applies to people, it applies to equipment, it applies to materials, tools, all of those things. Materials and equipment motions can be related to wait times and transportation, but they also result from poor workstation layouts, poor planning, lack of production standards and processes. In people, it may be related to excess physical motion, like a lot of reaching or bending or lifting, things that we try to look for if you do an ergonomic analysis to see how are you handling your workstation. But it can also be moving through the factory, doing a lot of different things. If you have to retrieve material here or retrieve tools here and move things back and forth. So if you think motion is one of your wastes, do a good ergonomic evaluation or assessment. Most companies today have access to people who are able to do that, and reduce the unnecessary motion of your people, your materials, and your equipment. And then the last one, which I think is a very powerful one, the last waste that they have added is underused talent. So this was added by companies who really understand that they want to utilize the full potential of all of their employees. It can apply to workers performing work without training as well. Or if you don't have documented processes to ensure the consistency, then you may be underusing your talent because you're not training them thoroughly, giving them the tools to go back and refer to things to help them be more productive and do that on a consistent basis. And remember, when we talked about the 5 S's, you've got to standardize this and make sure it sticks. So that's an important one. So there's 5 principles that you may have heard of. I'm going to talk about these. The first is value. So what is value in terms of the customer's perspective and the service parameters they're expecting? The value stream is the next one. This is a lot of project management analogies here. Once you understand the value and you've defined that, then you look through the processes up and down to understand what is actually adding value and then what is not. And I found that this can be a real eye-opening exercise because it documents all the steps it takes, and it can expose a lot of waste in the form of non-value added activities. And non-value added activities can include things like inspections, transfers, and wait times like we just talked about that you want to remove. I'm not saying every inspection should be removed, but when you look at the value stream and you're saying, okay, what value is the inspection adding at that point, you might say we don't need that. You can reduce, I've seen companies reduce their inspection points by half or even more because they looked at it, they mapped the value stream, they have the culture, and they have the workers involved in taking ownership and responsibility for the work they do. So if you have people looking at the work and making sure it's right before they pass it on to the next person, then you don't have to rely on an external inspector to come in and say, yes, you did that right. If you know how to do it, know what it should look like, then you don't necessarily need the inspectors on every step. So then once you have the waste identified through the value stream and remove those, then you want to look at the process for that flow. You're looking for interruptions. You're looking for disruptions, delays. You're looking for bottlenecks. This can reduce your cycle time and provides benefits in productivity, efficiency, and sometimes you can increase your productivity. You can double your productivity or more and increase your efficiency as well, depending on how you measure it. So get rid of the bottlenecks and the delays that are unnecessary. And then push versus pull systems. So I mentioned that a minute ago, and if you're not familiar with that, pulling means that you're really not doing a lot of manufacturing or not creating products or services until you have a signal that there's actual demand there. You can use pulling with forecasts if you have a very good handle on the forecast and you have the track record to say that this is actually tied to what customers want. Pushing means irrespective of that, you're building to the forecast and you're just building. And sometimes companies build and then they say, whoa, Nelly, that they've built too much and they have to cut that off and they have to evaluate the inventory they have. So most companies have a push-pull boundary established wherein they have materials purchased in anticipation of the production, but they delay all or some or even all of the production until you actually have an order from a customer scheduled or you have a solid demand from your sales team, a signal for demand from the sales team. So if you think about a bakery, this is an easy example, I think, to understand. A bakery always has butter, sugar, flours, eggs, vanilla, all of those kinds of things. They have those raw materials on hand all the time. And they should have, if they're running their business, they should have replenishment strategies. So when they get low, they bring more in. But they may not start production of certain types of things until the inventory gets low or until they receive an order for a particular item. So think about a wedding cake. Bakeries don't typically build wedding cakes in advance and in anticipation of someone needing a wedding cake. A wedding cake is something that if you're going to have even a small wedding, you have to order that a week, 2 weeks in advance, or even more. So, or maybe it's a unique birthday cake. If your child happens to like the circus or Star Wars or whatever that child likes, and you want a birthday cake created to that particular configuration, you're going to have to order that. If you like or dislike a certain element. So I have a friend whose children do not like chocolate, which I think is insane, but they don't want chocolate. So they don't want a chocolate cake. They don't want chocolate icing. They want yellow cake and white icing, or white cake and some kind of icing or whatever. So if you have a certain thing that you want, you might want to order that. But the bakery can do that because they have all of their items. In the meantime, they are making things on a push system. They're making cookies. Any bakery you go to, you can generally walk in and buy oatmeal cookies, chocolate chip cookies, brownies, maybe some kind of cake that they have that's pre-made. But they may make the cake and then they may hold some cakes back and not ice them until somebody comes in and says, oh, I'd like a cake, but could I get this kind of icing on it and whatever? And they say, yeah, come, if you wait, we'll do it right now, or come back in half an hour. So that would be the pull system, where making the cake and having it sitting in the back ready to be iced would be the push system. So most companies do a hybrid and don't wait to start anything until they have an order. Then finally, perfection comes in. And this is a principle that acknowledges that lean is really an iterative process. And you're not really going to get to a perfect level, but you need diligence and you need continued efforts from the entire organization to keep improving. So you're continuing to raise that bar. Lean experts say that a process isn't truly lean until it's been through the value stream exercise half a dozen times. So this is not a one and done type process. It doesn't mean that you have to start it immediately. It's not like the Golden Gate Bridge where they paint it, and then as soon as they finish, they start painting the other end and go back through it. This is not one of those, but you do have to have that continuing mentality to keep reviewing over and over and over. So lean organizations have a couple of traits you can recognize them by. Accountability. So they have daily processes, maybe daily huddles, stand-up meetings, different things, but they know who's accountable for what, and they're sharing that information so that if you're accountable, part of your responsibility is communication to make sure if there's something wrong that you're getting the help that you need as soon as you identify the issue, not waiting until it's going to be a problem that's felt by lots of people. In a lean organization, people lead by example and they do the practice what you preach. They understand the concepts, they embrace those, and you'll see that they transfer those not only from their workplace, but to their home. Or people who are lean by nature, more lean by nature at home, are the ones that are really helping drive that in the workplace. So you're leading by example, and you see leaders in the organization who are stepping up and modeling the behaviors that you'd like to see. In a lean organization, it is a very respectful organization. You see respect to anyone and everyone because every idea is worth hearing, and you see people communicating, listening, questioning, and following up. So that Gemba walk is really taking a walk around and making sure that you understand what is going on, but you're respecting every person's perspective that's involved in that process. And you're showing that respect in everything that you do throughout the day. They're also adaptive. These words, agility, flexibility, change management, all of those are in there, but lean organizations can do those things more quickly because they don't have as much waste to deal with. So they adapt to change quickly, they course correct on their, when they do find something, and so they are more able to be flexible and incorporate changes more quickly and more completely. It doesn't take them as long to institute a new process or system because, again, they have this lean concept. They are able to raise issues candidly. A lot of factories that I've been in my years have empowerment philosophies where anyone on the line can stop it if there's an issue, if there's a problem. Even if they have a serious question about something that's going on, they can stop the line, they can get the problem worked out, and then they proceed again. So you can raise issues candidly. It's a safe space. It's an honest assessment of things, and it's a teamwork process to everybody work together. And then there's a good balance between the strategical and the tactical in a lean organization. You see that strategy alignment, you see the alignment through the top level goals, through the middle level, and through the goals on the floor, with everyone knowing what they're doing to contribute to that. So you often have a war room, or maybe they have a board on the factory floor that says, this is how we're doing. And there's people responsible for updating that because that's part of the accountability. It's your job to post your results for the shift maybe. And that task alternates between people or rotates through the organization, but you have everyone looking at how they can communicate, how well they're doing very quickly, and get the help that they need when something goes wrong. So that is a lot of what companies can do, what you can do as an individual, what you can do in your workplace. I have a lot of information on Six Sigma, but I'm going to go through it really quickly because this is a lot. And if you have more questions, I'll show you at the end how you can reach out to me. I told you before, Six Sigma is 6 standard deviations, and it's actually on both sides of the mean, and it would mean 3.4 defects per million opportunities. There's a couple different processes that you use in Six Sigma. One is DMAIC. It's define, measure, analyze, improve, and control. And then there's another one, DMADV, which is define, measure, analyze, design, and then verify. So that may incorporate a redesign or a new design, and then verification that that works. So both of them start with a define process, which takes some time. Make sure you define the problem correctly, because if you don't, you're not going to be solving the correct problem. And then at the end, you're either verifying or controlling, which is a form of verification to make sure you get the results that you want and that they continue to be done. We've all probably worked in a process where we've made some changes. We made some changes, everything worked, and we thought that was done. We walked away, and then you go back 6 months later and they're back to the same old thing they were doing before, and you lost all the gains that you worked so hard to put in. We don't want that to happen. So with Six Sigma, they have a lot of focus on that. There's a lot of statistical terms here. Some of these are pretty straightforward, mean and average. Sigma is actually a standard deviation. So that's the extent of the deviation. And I'll show you a chart on that. Different types of data, different types of control charts, again, very statistically based. And I can give you a lot more information if anybody would like some of that. And you will get a copy of these slides. So Six Sigma here, you can see this is the normal curve, we call it. And Six Sigma, the 3.4 total defects is really out here, very, very much in the end, out here where this line is. So but you can see that these normal curves can be very broad or very narrow, and it can be right on target or it can be off of the target. So in this case, the target line is in the middle, and the blue line is the lower one is the really curve, is the better curve that you're looking at. But you can have a green curve, the one that's high and kind of narrow, that's still within your spec limits. LSL is lower spec limit, USL is upper spec limit. So you're within your spec limit and you have a pretty narrow variation, but you're not really hitting your target. So there's different things that can happen with statistics. This again shows you process averages. So you can see with the sigma here, one standard deviation to each side. If you're within that range, you have about 68% of your data points falling in that range. If you go out to the 2 sigma levels out here, then you're with 95%. And then within 3 sigmas on each side, that's 99.7%. But again, that's nowhere near the 3.4 million, right? 99.7 is 0.3 defects per every 100. So then in 1,000, it would be 30. And then in 10,000, it would be 300. No, I'm sorry, 0.3 in 100. Then if you multiply 0.3 times 10 for 1,000, it would be 3. And then 30, and then you can look at that and see. So you quickly get over the 3.4. But this 6 sigma here is what we're looking at for the 3.4 per million. And not every company needs that on every process. So it's a good goal, but you don't need that, and you don't need to spend lots of extra money getting that if what you have is sufficient. However, if you're doing things in the medical industry, if you're doing things in scientific work, or maybe in flight controls, you want that to be pretty good. I don't want much more defects than 3.4 per million in the bottle of Advil that I have sitting next to my desk for when I get a headache, or if you have some contamination of something that you don't want in your food, that needs to be pretty high. So look at your application for that. Here's some charts, X-bar and R charts. There are some different things that they tell you. You can see in the top chart, the X-bar chart, the top one, you can see that you've got data points that are going out of the range. But what's happening there is your process average is shifting upwards. But if you do a range chart, everything looks good because you're still within range. Because if you see on that top level that the width of that curve shape has stayed the same. You're just moving your mean. In the bottom one, you can see that you're changing the shape of that curve. It's getting wider and wider. It starts out nice and narrow, and then it gets wider over time. But if you look at your X bar chart, everything is good. You're still within range. You're still, looks like you're in control. But your R bar chart will tell you that you got a trend going on here that's not going in a good direction. So they tell you different things. There's P charts and C charts. C charts are for things that you count, numbers of defects. P turns that into proportions or often percentages. So you have a point, you have a 2% issue or a 98%, and it usually tracks defects, not goodness. So it's a 98% yield is a 2% defect. Your P chart would show you the 2%. And you can see on this chart that there's 0.01, 0.02, which would be the 1%, 2% factors. Here's your DMAIC model: define, measure, analyze, improve, and control. And here's your define, measure, analyze, design, and verify. So two different things you can use. There's a lot of other tools that companies use. They use the 5 whys, ask why at least 5 times. If you have a child, they've asked you that many times. Why is the sky blue? Because. Why is this? Why is that? Because. So they get to maybe frustrating you very much, but that can be a very good exercise. Just in time, pull systems, plan, do, study, act, plan, do, check, act. People have seen those. Check sheets, bottlenecks, a lot of different things to use there. Certifications in Six Sigma, you can get some certifications. White and yellow belts are often in company training programs that companies have and create for their own use, which are very good. Green belts typically have more certification from an outside organization. I got my green belt when I was working for a corporation, but it's through the University of Michigan. So I had to do some testing, take some tests and learn some material, and then actually do a project. Black belts and master black belts are higher. Black belts, again, have to lead programs and have a third party certified that they've done that, and they have the certification in place that they've led the project, and it's a bigger project, takes more time, more statistical knowledge required. You can take courses in these as well at a lot of community colleges and universities around the country, extension programs. And master black belts are in charge of black belts for an organization. And then you have champions, and sometimes sponsors is used. So those are the people within the company that really help identify the projects. They ensure the availability of resources, and they are intended to help you remove obstacles so that you can get done what you want to get done. So there's a better way to utilize Lean and Six Sigma philosophies than in some applications I've seen. One of the first things companies see when they try to implement these methodologies is they see an improvement in employee morale, because you're getting employees involved, and that's a great thing. So Lean and Six Sigma rely on subject matter experts, typically the people closest to the work, and they're the ones doing the work. And they see the targeted improvements, and they actually experience the improvement from making the change in the process or the procedure that they're working on. Their knowledge and insights are really key to making these desired changes and improvements in the first place, and they're invaluable when you're trying to make sure that they stick. If you get out of the box and look at operations and tasks from a customer's perspective, it's not unusual for customer satisfaction scores to go up, and complaints and returns are going to decrease. So that's a good thing to do. And it's basic math. Revenue minus expenses equals profits. And if you look at waste, it is a cost and expense. So if you can reduce that and keep the same revenue, then you're going to increase your profit. So it's a really good thing to do. Corporate cultures are influenced positively by that. It promotes teamwork and job growth opportunities, which is also something that employees are really looking for, is what's in it for me, and what kind of a better job am I going to get out of this? And black belts who have an average salary of about $80,000 generate typically $230,000 a year. So they're saving not only their salary, but 3 times their salary. So they're paying for themselves and 2 other people in order to get that done. So those are some statistics that are fairly common in the workplace today. So that's our dynamic dialogue for today. Next time we're going to be on August 10th, and I'm going to talk about leveraging supplier relationships. On the 7th, it's not the 17th, it's the 24th. I'll have to fix that. We're going to do capacity planning with suppliers. So if you want to learn a little bit about capacity planning and what you can do to work with your suppliers on that, join us on the 24th. If you're interested in future discussion or talking more about Lean and Six Sigma, you can set up a free call with me at callwithjane.com, or you can reach out to me at my email address. If you want to look at our workshops, we're planning on doing a couple of workshops this fall, one on Lean and Six Sigma in October, one on risk-based thinking in September. And then we're going to have a CPSM exam starting in September that will end around the time of Thanksgiving. So you'll have time to take the test and celebrate Christmas and New Year's unencumbered. And finally, I want to leave you with this. Bruce Hamilton is the president of the Greater Boston Manufacturing Partnership, helping companies implement lean concepts. He's been working with the Shingo Institute, and he has a Shingo Prize for a lot of the work he's done with lean. And he says, continuous improvement is not about the things you do well. That's work. Continuous improvement is about removing the things that get in the way of your work. The headaches, the things that slow you down. That's what continuous improvement is all about. And I really like that, because that's what lean is really trying to do. Is it's not trying to add to your plate. It's really trying to get those obstacles out of the way, reduce your headaches, and help you do things more clearly. So that's what I have today. I'm gonna stop the recording, but I will stick around and take questions if there are any.